Hello, everybody. Today we're going to be talking about our 7.5 notes, which covers spheres and solids of revolution. Spheres is the last kind of three-dimensional shape that we will talk about in this unit. And spheres have their own formulas that do not look like any of the other formulas that we have talked about so far. So when we talk about spheres, spheres do not have differentiated areas. Like they don't have a lateral area and a surface area. All they have is surface area. So instead of having three different formulas, we only have two, which is going to make our lives a little bit easier. The only difficult part of this is the formulas are a little bit similar. Like they're kind of similar, but they're also a little bit different. So you just got to be prepared for what you're about to see. So the formula for the surface area of a sphere is going to be 4 pi r squared. Okay, so it looks very similar to area of a circle, which is pi r squared, but then we throw a 4 in front of it. So 4 pi r squared is our surface area formula, and then volume is going to look very similar, but now it's going to be 4 pi r cubed, and then we have to also go in and divide that by 3. Okay, so we got to make sure that we know the difference between surface area and volume. They look similar, but they are not. All right, spheres are pretty easy though. So example 1 says, if the radius of a sphere is 5 inches, find the surface area and volume. So we know that our radius is 5, so all we have to do is plug that in to our area and our volume formula. So surface area is going to be 4 pi r squared. So this will be 5 squared is 25 times 4 pi, which is going to be 100. Just double checking my math. 100 pi, and then this is going to be inches squared because it is surface area. And then I need to go in and find volume. So volume is going to be 4 pi r cubed over 3. 5 to the third is 125. So this is going to be 4 pi times 125 over 3. I'm going to multiply 125 by 4 first, which is 500. So this is going to give me 500 pi over 3, and I don't think 500 divides by 3 evenly. It does not, so we're actually just going to leave it at 500 pi over 3, and this will be inches cubed because, again, it is volume and our units are cubed, and that's really all you have to do. Let's scroll on down here. Example 2, it actually gives us the volume instead of giving us the radius. So this is going to be what I lovingly refer to as a backwards problem, where we are going to write down the volume formula. So volume is 4 pi r cubed over 3. And then I'm going to plug in what I know. So I know that the volume is 288 pi, and that's going to equal 4 pi r cubed over 3. So because there's a pi on both sides, I can actually cancel out that pi, and then I'm going to go ahead and multiply both sides by 3 to get it out of the denominator. So 288 times 3 gets me 864. So right now I've got 864 equals 4r to the third. We will divide both sides by 4, and we get, coming over here, we get r cubed is going to equal 216. And as a reminder, you can actually do a cubed root in your calculator. To do that, you need to go find the math button. So go find math. And then this is if you have a TI 83 or 84. And it's going to be the fourth option down, which says 3. And then it looks something like this. Okay, so that's what you're going to click on. You click on that, you type in 218. I just lied to you. You type in that, and you type in 216. Come on, calculator. There we go. And you get that the radius is going to equal 6 meters. And there you go. All right. This is one of my favorite examples. It's a little crazy with the wording, but just bear with me, okay? It says, find the area of a circle. So first thing I want to point out is it's asking for the area of a circle. Area of a circle is referring to a two-dimensional circle. So we are looking for a two-dimensional shape right now, okay? So we need to find the area of a circle that is formed when a plane passes 7 centimeters from the center of a sphere with a radius of 8 centimeters. So you can kind of draw this circle wherever you want within your sphere. We just know that it has to be 7 centimeters from the center. So what I'm going to do is I'm going to create another shape that looks similar to the one that you see down there, okay? And I just need you to know that this right here is a circle, Okay, I'm trying to figure out how I can describe this. So like if you, for example, take an orange, okay, or any kind of round fruit, and you take a knife and you slice off part of the top of the orange or any other circular fruit that you have, you're going to end up with a circle at the top. And they're essentially asking, what is the area of that circle that gets formed if you were to like shave off the top part of an orange? So we're looking for the area of that pink circle that you see. Now, it tells us that this plane is passing 7 centimeters from the center of a sphere. So what we know is here's the center of my sphere and the center of the circle. That length right there is going to be 7 centimeters. Okay. It also tells us that the radius of the sphere is 8 centimeters. So I'm going to draw this, but I don't want you to draw it. I just want you to watch for a second. Okay. This is going to be 8 centimeters. In order for me to find the area of a circle, remember that area is pi r squared. This isn't surface area. This is just area of a circle, okay? Area is pi r squared. So for us, we have to have the radius of the circle, not the radius of the sphere. But I don't have the radius of the circle. I only have the radius of the sphere. And where I've put the radius of the sphere isn't really going to be very helpful to me. So the thing that you need to remember about radii in a circle or a sphere is you can put it wherever you want. As long as it goes from the center of your circle or sphere to an edge, you're good. So what I'm going to do is I'm actually going to take this and I'm going to move it, if I can figure out how to do that. I'm just going to have to erase it because it's not going to do what I want it to do. But instead of doing it on the edge there, I'm actually going to draw it from the center of my sphere and I'm going to draw it to where the circle meets the sphere's edge. And that is going to be 8 centimeters. And now that I do that, I can draw a radius of my circle. And that's what I need. So essentially, I have a right triangle. So I'm going to use Pythagorean theorem to find r. So I've got r squared plus 7 squared equals 8 squared. All right, so 8 squared minus 7 squared gets me 15. R squared equals 15. So when you square root both sides, you get that the radius is the square root of 15. So I'm going to take this and I'm going to go, I'm going to plug it in up there. Okay. So the area is going to be pi times my radius squared. Well, the square root of 15 squared is just 15. So the area of the circle is going to be 15 pi centimeters squared. And that is the radius of, that's the area of the pink circle. All right. Now, we're going to move on to this lovely thing called solids of revolution. And what I want you to do is I want you to imagine that you have a 2D shape. For us, we're going to be talking about a rectangle, a triangle, and a circle. And we're going to be taking these two-dimensional shapes and we're going to be rotating them about an axis. When you do that, you end up creating a three-dimensional shape. So if you look at the images here, I've given you 3 different things. So when you have a rectangle and you rotate it about one of its sides, you're going to get a cylinder. When you have a triangle and you rotate it about its altitude or whatever, you get a cone. And if you take a circle and you rotate it about its diameter, you're going to get a sphere. Okay. So you have to know what each of these two-dimensional shapes create when they are reflected or rotated about an axis. Okay. So the best way for you to do this is to draw a picture. Okay. And I know that we're not all artists. That's okay. So here's our first example. There's so much going on here. Okay. First example says rectangle ABCD, and then it gives us dimensions for this rectangle. So what I'm going to do is I'm first going to draw me a rectangle. And I'm not going to draw it super big. I'm just going to kind of draw it here. And I'm going to label it A, B, C, D. It tells me that AB is 6 inches and BC is 10 inches. It says this rectangle is rotated about side BC. So what I'm going to do is I'm going to rotate this circle about side BC. This means that BC is staying where it's at. And my, I'm going to get rid of those arrows. And then my rectangle is going to get rotated about that side. Okay. So anytime you rotate a rectangle about a side, you're going to get a cylinder. So we have to figure out how to draw our cylinder. So what I always suggest is you are going to draw a dotted cylinder or a dotted rectangle on the opposite side of that pink line, because that's the pink line that I'm rotating around. So I'm going to draw me a dotted line here and a dotted line here, okay? Once I do that, I have to connect the dotted side to the solid side. And I'm going to do that with some arcs. And I'm going to add another arc to it. And that is the orientation of your rectangle, okay? So hopefully you guys can see the 3D shape that gets formed. Okay, you see the cylinder, and hopefully you can see that it's kind of a cylinder on its side. So now that we know that we have a cylinder, we have to sketch the solid, which we just did, and find the surface area and volume. So remember, with surface area and volume, you need P, H, and big B. You don't need L because you only need L with cones and pyramids. So P is the perimeter of the base. Our base is a circle, so our perimeter is going to be circumference, which is 2 pi r. The radius of your circle is going to be 6. So this will be 12 pi inches. Okay. Height is going to be the height of your cylinder, which is going to be for us 10. So the height is 10 inches. And then big B is area of the base, which is pi radius squared. So that'll be 36 pi inches squared. Okay, so there's my pH and my B. Now, surface area of a cylinder, you've got to remember all of these things. Surface area of a cylinder is P times H plus 2B. So I've got 12 pi times 10 plus 2 times 36 pi. So we've got 12 times 10 plus 2 times 36, which is 192. So right now I've got 192 pi inches squared for my surface area. And then the other thing that I need is my volume. Okay, so this is surface area. And then the other thing that I need is my volume. And volume is just big B times H. Big B is 36 pi. My height is 10, so that'll be 360 pi inches cubed for volume. And there you go. All right, example 2 says, does the rectangle in example 1 have the same surface area and volume if it is rotated about side AB? The answer is going to be no, and that's because your radius and your height change. Your radius will become 10 inches, and your height will become 6 inches, which is not going to give you the same dimensions, okay? So just know that it matters which side you rotate it around whenever it gives you that side. Okay, so let's look at example number 3. It says equilateral triangle ABC with sides 8 centimeters is rotated about an altitude. So I'm going to draw us our triangle. You've got A, B, C. We know that each of these sides is 8 because that's what it told us. And then it says it's rotated about an altitude. I'm going to rotate it about this altitude, that one that goes from the bottom down. Now, it doesn't really matter which way you rotate it, just it's going to get rotated around. Now, normally what I would do is I would say, okay, you're going to like draw your dashed line, right? But this triangle is already kind of drawn for you. So all you're going to have to do is make a circle for the bottom so that you see that what you have now is a cone. And I probably could have done this line a little bit better. Whoopsies. I'm struggling. Okay, so we're going to go this way, and then we're going to go this way. And now you have a cone, okay? So when you rotate a rectangle, or sorry, when you rotate a triangle about an altitude, you're going to get a cone every time. So what happens is now that I have this cone, I'm going to just kind of redraw this cone over here so we can look at it a little bit better. All right, I know that this side is 8. And then if we look at the bottom, remember that the bottom is also 8. So we can split that in half and get that to be 4. And so now what I have to do is I have to find the height of this cone, okay? So we can do h squared plus 4 squared equals 8 squared. So we've got 8 squared minus 4 squared, and that's going to equal 48. We will square root both sides, which will be 2 and 24, 2 and 12, 2 and 6, oh no, 2 and 3. You've got 2, 4, 3. So the height is 4 root 3, okay? So I've got P, H, B, and my slant height. Our slant height is 8 centimeters. The height is 4√3 centimeters. So now I need my perimeter, and because my base is a circle, my perimeter is circumference, which is 2 pi r. So this will be 8 pi. And then my area, my area will be pi r squared, which is, hold on, I'm thinking pi, radius is 4, so that'll be 16 pi centimeters squared. All right, and now I need to find the surface area and the volume. So surface area of a cone is P times L divided by 2 plus B. So that's going to be 8 pi times 8 divided by 2 plus 16 pi. So 8 times 8 is 64, divided by 2 is 32. So you've got 32 pi plus 16 pi, and that's going to get us 48 pi centimeters squared for surface area. And then volume is going to be B times H divided by 3. So big B is 16 pi, height is 4√3 divided by 3. So 16 times 4 is 64, divided by 3 is disgusting. Okay, so it's 64 over 3. All right, so I'm going to move this over here. Volume is going to equal 64 pi square root of 3 over 3 centimeters cubed. And that is the volume of my cone. All right, let's move down here to example 4. It says the segment that joins 0, 0, and 3, 4 is rotated about the y-axis. So let me draw that first. 0, 0, and 1, 2, 3, 1, 2, 3, 4. All right, so here's a segment. It says it's rotated about the y-axis, which means that it's going to be over here somewhere. So 1, 2, 3, 1, 2, 3, 4. So here it is if I rotate it around the y-axis. Okay, the y-axis is the place that I have rotated around. Yeah. So it says, sketch the solid of revolution and find the surface area and volume of the solid that is formed. Well, hopefully, if you imagine this line swinging around, it's going to be a rounded bottom with the point stuck where it's at. So like at 0, 0, that point doesn't move. And then the line is getting, I want you to envision this. I'm using my arm, and I know you can't see me, but I'm using my arm right now, and I'm holding my elbow. And what I'm doing is I'm rotating that around to the back and then back around in the front. And when you do that, I hope that you are able to see that a cone is formed, okay? And what we need to do is we need to figure out the surface area and volume of this cone, okay? So what I'm going to do is over here, I'm going to kind of redraw like a right triangle. I wish it wasn't so thick, but that's okay. Okay, so this is 1, 2, 3. So this is 3. This is 1, 2, 3, 4. This is 4. So that means that this is going to be 5. Okay, so now we've got our pH and B. We've got P, H, L, and B. P is the perimeter of the base. That's going to be 6 pi units. The height is going to be 4 units. The slant height is 5 units. And then big B is area of the base. 3 squared is 9. So that's going to be 9 pi units squared. Okay. So what we need to do is we need to find the surface area and the volume. I'm going to move this over a little bit. So surface area of a cone is P times H, P times L divided by 2 plus B. That's going to be 6 pi times my slant height divided by 2 plus big B is 9 pi. This is going to be kind of nasty. 6 times 5 divided by 2 plus 9. And I lied, it wasn't that bad. So the surface area is going to be 24 pi units squared. 30, 15, yeah, okay. And then your volume is going to be big B times H divided by 3. Big B is 9 pi. Our height is 4 divided by 3. 9 times 4 divided by 3 is 12. So the volume is going to be 12 pi units cubed. And there you go. And then last one. How would your answer change if you rotated the triangle bounded by the segment and the x-axis? Okay, so let's envision this again. So you've got 0, 0, and you've got 1, 2, 3, 1, 2, 3, 4. So here's our segment again, okay? It says, how would your answer change if you rotated the triangle that was bounded by the segment and the x-axis? Okay, so here is the x-axis down here. So what's essentially happening is I'm actually going to rotate this triangle, but this triangle is getting rotated the same way that we rotated just the segment. So I've got 1, 2, 3, 1, 2, 3, 4. So I'm coming over here. Okay, and essentially this is what's happening. But this is a little bit different because when you have a solid image, like this blacked out triangle that I have, and you rotate it, any mass that is within that solid space is going to be solid. But any mass that is not within that dark shaded space is going to be essentially empty. So what happens is I'm no longer rotating this image at a point at 0, 0 like I did a second ago. I'm actually rotating a line segment at the bottom. I'm rotating this. This line right here, I meant to do that with this right here. This line right here is what's getting rotated, okay? So what's happening now is there's still a cone that gets formed at the top, but the cone is empty. And at the bottom, I get something that looks like this. So essentially what you have is you have a cylinder with a cone removed from the top of the cylinder. Okay, so this is what's happening. You have a cylinder with a cone removed from the top. So now you have the same volumed cone that we found up here. We found the volume was 12 pi units cubed, but we have a cylinder that we need to find the volume of and then remove the volume of the cone that we found earlier. Okay, so what I need to do now is I need to find pH and B to use for the cylinder that is actually now in this image. So the perimeter of the base doesn't change. It's still going to be 6 pi. The height is still 4, and big B is still going to be 9 pi units squared. But I'm focusing on the volume of a cylinder. Okay, volume of a cylinder is B times H. So that's going to be 9 pi times 4. That's going to be 36 pi. So that's the volume of my cylinder. And then remember that I've got to subtract the volume of the cone, which was 12 pi. And when you do that, you get 36 pi minus 12 pi. I'm just double checking. 36 pi minus 12 pi is 24 pi units cubed. Woo! That was a little bit of a doozy. Anyways, these last two are going to be kind of the hardest for you. But just know that this is how you do the solids of revolution. And you'll eventually see a circle that gets rotated about its diameter. It just creates a sphere. If you have any questions, please go see your teacher during their normally scheduled tutorial times. And I will see you in the next video. Bye-bye.